Hello, everyone. Thank you for coming. So I'm going to speak to you about Ethereum, the DAO, and the very recent hack that happened. Who here has used Ethereum? All right, I see some hands, nice. Who knows about the DAO? Oh, good. Okay, so let's say something about me. I love systems programming and AI. I have been working in Ethereum since 2014. I worked in the C++ core in Berlin, and I specifically worked in ETHAS, proof of work algorithm, and in the Solidity language itself. Since the end of, since last December actually, I have been the tech lead of Slockit and have contributed to the DAO code. Originally, this presentation was going to be only about Ethereum and kind of a more in-depth dive into Ethereum, but due to the recent events with the DAO, I thought it prudent to divide it into three sections. So in the first one, we're going to see a little bit about Ethereum, what the protocol is, and go through the basic components. In the second section, we're going to see what the DAO is, in case some of you are not familiar with it. And in the third section, and the most painful for me, we will explain what the DAO hack was, how it happened, and what its consequences have been. So, Ethereum. Ethereum is a public blockchain platform with programmable transaction functionality. Essentially, it provides a decentralized virtual machine that can execute peer-to-peer contracts, and it uses a cryptocurrency called Ether. It's much like Bitcoin, but it's using a Turing-complete programming language called Solidity. Essentially, people write programs and they deploy them in the blockchain, and these programs are known as smart contracts. They function as little black boxes of code that execute their code as soon as they're activated by external stimuli. The blockchain, combined with the smart contracts, are what makes Ethereum a unique blockchain platform. Essentially, Ethereum enables people to create something that we like to call dApps, so decentralized applications. So every user that runs an Ethereum node has an account, and he creates transactions that pushes them into the network, much like Bitcoin. The people who create the new blocks, they are called miners, and they verify all of the transactions that exist in the network. And if a transaction is successful, they include them in the blocks. All nodes synchronize new blocks from the network continuously and slowly build the decentralized ledger that is the Ethereum blockchain. Accounts in Ethereum are very simple. They are using the elliptic curve cryptography digital signature algorithm, and they generate a private and public key pair. So your Ethereum account is essentially the rightmost 20 bytes of the public key. Each account has a specific balance, a nonce, which is what we use in order to make sure that this transaction is only processed once for an account. And accounts are separated in externally owned accounts and in contract accounts. An externally owned account is what you or me would have for an account that's not a contract. And the contract accounts are accounts that have code and storage. And all of this is stored in the Ethereum blockchain. Just like Bitcoin has, well, Bitcoin as the fuel of the as a cryptocurrency, in Ethereum we have Ether. Ether is the token that fuels the Ethereum ecosystem, and it is subdivided into it has many denominations. The most common of which is the Wei. So one Ether is equal to 10 in the power of 18th Wei, and this is what you will have to deal with if you play with Ethereum. There is also 10 in the power of 6 Sabo, 10 in the power of 3 Fini. Right now, Ether is roughly about 11 euros. It's priced at about 11 euros. In Ethereum, we have the concept of gas. If you're a StarCraft fan like I am, it has a very nice correlation. Because most of the times you will not have enough gas, just like Vespene gas in StarCraft. So in Ethereum, gas is very important because it is what protects the system from DDoS attacks. Every single transaction, every single opcode inside the EVM costs gas. So someone cannot just DDoS the network by making transactions because he will have to pay transaction fees. Every opcode costs gas. So yeah, so the price in Ether that you are paying is determined by something that's called the gas price, and this is something that you set on your own, but by default it is at 50 Sanon. And the problem that you will always have is that you will end up needing more gas. Much like Bitcoin, Ethereum has proof of work mining at the moment. That means that the miners use an algorithm called ETHAS, which is the current proof of work algorithm in Ethereum. And they verify transactions that go into new blocks. ETHAS has a unique property that is it requires a lot of memory. And because of this, it is ASIC resistant. That means that there cannot be made many special chips that are made only for mining. Currently, people who mine Ethereum have something like this picture, so a GPU mining rig, because only GPUs can actually give you any mined blocks if you're mining Ethereum. A very important part of Ethereum is the transactions. Transactions are essentially signed messages that are sent from externally owned accounts. The transaction contains many attributes. The message's recipient is an attribute, the sender, which is identified by a signature, an optional data field, which is what ends up calling code, and of course the gas value. If the message's recipient is also a contract, then that contract's code is executed. There is another thing in Ethereum called messages. Messages are essentially exactly like transactions, but instead of being sent by externally owned accounts, they are what is used for machine-to-machine communication. So essentially, contracts send messages to each other. Messages are exactly like transactions, so they have a recipient, a sender, an ether value, and the only difference is that they are sent by contracts to each other. So Ethereum has a very simple state transition function that takes you from a state A to a state B of the blockchain by applying a transaction. Essentially, what we do with this state transition function is that we check if a transaction is well formed. So if the signature is valid and if the sender nonce is correct, then the gas price, the starting gas price is calculated, and we see if the sending account has enough gas. Then every byte of the data is calculated, and if there is not enough gas in the sender's account, the transaction throws. By throwing, it means that the transaction is not complete and it's not put inside the blockchain, but still the sender is charged gas, because this is what would protect against DDoSing. If, on the other hand, the transaction is valid, then the state of the blockchain is updated, and the miner gets the gas fees, and then we continue with the next transaction. So what makes Ethereum unique compared to Bitcoin, for example, is that we have the Ethereum virtual machine, which is essentially code that is what all of the smart contracts are made of. So the EVM, as it's known, consists of a series of bytes, and each byte is essentially a different operation. So, for example, 0x50 would be popping an item from the stack. 0x52 would be storing something to memory, and so on and so forth. The EVM logic is very simple. The code execution happens in an infinite loop, and the opcode at the current program counter is always executed, and then the program counter is incremented. That happens until the end of the code is reached, or a return or an error instruction is found. All of these computations have access to 3 different types of storage. One is memory, which is an ever-increasing byte array. The second is the stack, which is a typical stack, last in, first out data structure. And the unique part is the contract storage. So contracts can actually store things in the blockchain. And as such, if you store something in the blockchain, it stays even after the transaction is over. On top of this EVM, there have been many languages that are built. One is Serpent by Vitalik Buterin, which is a kind of a Python-like language. The other is Mutant by Jeffrey Wickle, and this is a Go-like language. And the most used one currently is Solidity, and this is the one that the Ethereum Foundation recommends that people use. Solidity code looks kind of like this. I don't know if it's really visible. Essentially, it's a JavaScript-like language, but it's object-oriented. And where we have classes in other languages, here we have contracts, so smart contracts. Contracts can inherit from each other. They have functions that can call into other contracts, and due to the object-oriented design of the language, functions can also be overloaded. Languages like Solidity essentially enable us to create the decentralized applications, what we call as dApps. Essentially, a dApp is what makes Ethereum a unique ecosystem. A dApp consists of the set of smart contracts and the client-side code that interacts with those contracts. And you require an Ethereum client in order to do that. They're much like typical web applications, but instead of the server-side code, you have the smart contract that is running in the blockchain. Some examples are, for example, prediction markets like Augur, or a decentralized social network. That's quite a very new one, Akasa, where it would be something like Facebook, but it would not be stored in a centralized server, but instead it is stored in the Ethereum blockchain. And of course, another kind of dApp is what we're going to talk about in the next section, which is the decentralized autonomous organizations. So from here on, we're going to talk about the DAO. So what is the DAO? The DAO is a decentralized autonomous organization, so a smart contract that lives in the Ethereum blockchain. Its purpose is to create value for its members, for its token holders. It creates proposals for funding projects that will eventually give profit back to the organization. It's something that's not stored anywhere. It's only in the Ethereum blockchain, and it's something that has never been tried before. And we started working on this as a company. Sloki started on this development essentially almost a year ago. It's all open source in GitHub. There have been over 860 commits. It was developed by people from the company that I work for Slockit, but also by a lot of Ethereum community members. And there was a security audit by a company called Deja Vu, and by many members of the Ethereum community. Essentially, the DAO has also its own token, which has this is the symbol of the DAO token, and it represents the amount of voting power that you have in the DAO. So if we assume, for example, that there is a DAO that has 100 Ether, and you have 50 tokens, essentially you own 50% of the Ether inside the DAO. and your voting with your tokens would be 50% of the votes. Just like any other currency, they are fungible, so that means that one can be exchanged for the other, and they are also tradable. You can go now and trade tokens in major exchanges like Kraken or Poloniex. The DAO has a fail-safe mechanism called the curators. The curators essentially are a multi-signature wallet of 12 people, many of whom are prominent members of the Ethereum community, including Vitalik Buterin, who is the creator of Ethereum. They are the ones who curate the whitelist. So essentially, the list of accounts that can receive proposals from the DAO. But what is a proposal? Essentially, a proposal is a way for DAO token holders to influence actions of the DAO. We have a UI, and many other people made different UIs for how proposals should look like. Essentially, proposal just requires you to be a token holder in order to make it, and it takes 14 days of debate period. During these 14 days, everyone can vote on a proposal. So in order for the proposal to pass, it requires a majority vote and something that is called to reach the minimum quorum. So the quorum is how many of the token holders actually participate in the vote. The quorum that is required ranges from 20 to 53.3%, and that depends mainly on how much money of the DAO you want to spend. So if you say you want to only spend 20% of the DAO's funds, then, if say you want to spend no money, but just want to make a function call, then it will be 20% of the DAO token holders. While if you want to spend all of the DAO's money, you would require 53.3% of the token holders to take part in the vote. And essentially, a proposal is specifying a transaction that the DAO should perform, just like the transactions that we saw in the previous section. There is another kind of special proposal in the DAO that's called the split. The split is a way for a DAO token holder to get out, to leave the DAO. It requires a special 7-day proposal, and what it essentially does is create a very new DAO and moves all of the Ether that was backed by the creator's token into the new DAO, so you get your money out, but you also burn your tokens inside the old DAO. This was initially conceived as a way to vote against the curators. So if the curators turned out to be somehow malicious, then all of the token holders can create a split and move into a new DAO and have a new curator. So the DAO started, essentially, it was born by a community member on the 30th of April 2016. During the creation phase, or also called fueling phase, which was 28 days, people could buy tokens into the DAO. The price was, in the beginning, it was linear. It was standard. One Ether gave you 100 tokens, and after the first 14 days, there was a linear price increase until 1.5 Ether would give you 100 tokens. The DAO did much better than anyone of us or anyone I know in the Ethereum community ever expected. It raised 12.1 million Ether. What that means is, at the time, because the price was much higher back then, at the time that was over $220 million. It was an amazing amount. Once that got finished and all of the Ether was raised, then people started making proposals to the DAO as it was planned. So companies like Mobotic made a proposal to the DAO in order to create autonomous vehicles and to give back a percentage of the transaction to the DAO so that the DAO makes some profit. my company also, Slockit, we were going to make the proposal for something that we call the universal sharing network. So a way to share anything that you own, to rent it via the blockchain, and all of your, a small percentage of this transaction would go back to the DAO as profit. Slowly, because the DAO, of course, was not perfect. The next versions were being prepared. I don't know if you can see it, but essentially this is just pull requests and milestones. So DAO version 1.1 and DAO version 2.0 were started to be coded, and many members of the community started to participate. The problem with this is that the DAO upgrading is also a proposal, so it also has to take 2 weeks. 2 weeks in order to have a vote and then execute the proposal. So the DAO upgrade process is not something that can happen fast. That's why the proposals were, the pull requests were, and the DAO was preparing to get upgraded. We also introduced a method through which the community could make decisions on how the DAO should be improved, so the DAO improvement requests. If any of you are familiar with Python, so for example the PEP, Python enhancement proposals, this is something similar, so that a community member can essentially say what he would like to see different, why this new feature that he would like to see implemented is needed, and maybe also make an example pull request, and then the community has to vote and see if this feature should be in the DAO. So everything was going well until the hack happened. So in this section, I'm going to speak about the timeline of the hack and how the DAO got hacked and what exactly happened. It started not long ago, essentially on the 10th of June. Christian Reitwiesner, the creator of Solidity, made a blog post that was not really given a lot of attention, but in there he essentially wrote about an anti-pattern in Solidity that could be very dangerous, and unfortunately up to that point all of Solidity code, including the DAO code, was written using this anti-pattern, and all of the tutorials were using this exploit, and nobody had seen it, not even the creator of Solidity. Essentially, now this is Solidity code, even though you may not, I don't know how well you see it, but the point of this is that at the point where you call to transfer money, so if not message sender call value, at this point, you send some money, and afterwards you change your internal accounting. So you change the user balance of message sender to 0. This makes sense when you first look at it, but unfortunately, if you change the balance after you send money, you are unfortunately vulnerable to an exploit like this. Because when you send money to a contract or to an account, to any account essentially, you call the fallback function of that account. And that fallback function could be a malicious function just like this one, and call back the contract that called it recursively. And if you do that, you end up going back in the same function. If we look back, we would be, we would be back at withdraw balance, and we withdraw again, and then again, and then again, and there will be a transfer of money recursively. So this was what that blog post was about. The next day, on the 11th of June, another big decentralized application, MakerDAO, was brought down by its creators because they realized that they were vulnerable to this exploit. They could do that because they still had some form of centralized control. It wasn't completely and idealistically decentralized like the DAO was. So they managed to save all of their token holders' money and transfer it to a secure multi-signature wallet. The next day, we announced that the DAO was also affected. The functions that were affected was the refund function, which is essentially something that would be called only if the minimum funding goal was not reached. So that, even though it was affected, it didn't really have any problem because the refund function could not be called at that point. An exploit was discovered in the new contract, so in the upgrading process, but that was also safe because the upgrading process would be curated by the curators. But then we discovered the same exploit in execute proposal and the withdraw rewards for functions, at which point we understood that the DAO should stop any operations and start an upgrade process. Unfortunately, as you may remember, I said that the upgrade process itself is also a proposal, so it will also take 14 days to complete. So we had 14 days from the 12th of June to come up with a new code, make a proposal, and vote on it, and essentially upgrade the DAO. It would be nice if we had enough time, but unfortunately we didn't. So we started making PRs. So this is a PR by myself in order to correct the exploit in the withdraw rewards for. As you can see, essentially it's just moving one line before the transfer of value. It's extremely simple. It's so simple that it hurts. Because 4 days later, on the 17th of June, I was woken up by a call at 6 in the morning by our community manager, Griff Green. He told me that, hey man, something is wrong. The DAO is being drained somehow. So we all got online in the morning and started to see what's happening. This is, for example, a blockchain explorer called Etherscan, and here you can see recursive calls being made from a malicious contract to the DAO, draining a little bit of Ether every time, 130 Ether every time, slowly. It didn't take us long, of course, to realize that someone found an exploit that we had not seen, and we saw it immediately. The vulnerability was a combination of two functions, the split DAO function and the withdraw reward for function. At the end of the split DAO function, we have this withdraw reward for with the very neatly placed comment, be nice and get his rewards. So at the end of splitting, when a user splits and creates his new DAO, we also are kind enough to withdraw his reward for him. And as we said before, the exploit is that the internal accounting should be always before the transfer of value. This is what we should have done, but the code was already deployed, so the attacker used this. And inside withdraw reward for the same thing, the paid out, so the internal accounting should be before the transfer of value. That's the whole exploit, essentially. This attack lasted for about 5 to 6 hours, and it created a new DAO, what the community likes to call the dark DAO, and 3.6 million Ether are inside there. The attacker stopped. I have no idea why he stopped. The only thing that I can imagine is that he didn't want to take everything because he thought that he could get away with 3.6 million. Due to the way that splitting works, it creates a new DAO, and this also goes through a 28 days creation period. So nobody can touch this money, not even the attacker, until the 14th of July. Unfortunately for everyone, the attacker controls both of the accounts inside that DAO. He was really careful to pick a split to join and perform the exploit where nobody else was. So there was a very, very, very sudden and immediate aftermath. the DAO price crashed immediately, in the same hour. It fell to almost 0.05 Ether, which is essentially the normal price would be 0.01 Ether. And people started panicking because they wanted to save their money, as is understood. And they started joining random splits. So here are splits that were happening at the time. And people started joining them, thinking that they will be able to save their money, even though that was not really possible. Due to the fact that when you split, what you are taking with you is the amount of the percentage of Ether of the total supply backed by your tokens. And since the hacker had already taken money out of the DAO, everyone who was splitting at a 70% loss. Still in the same day, the internet exploded, at least my corner of the internet. All major news outlets started reporting on the hack. Wall Street Journal, New York Times, Business Insider. Headlines like $50 million hack just showed that the DAO was all too human. The price of Ether was soaring. It was at 19 euros in the morning, and by the evening, it fell at 10 euros. It has not recovered since then. It was evident that the DAO was a hacker's picnic at that point. The exploit was very well known. Anyone could take the remaining money. So a group that will remain anonymous for now, they like to call themselves the Robin Hood group, decided that it's time to perform a white hat attack on the DAO in order to secure the remaining money. So essentially, the white hat group used exactly the same exploit in order to siphon the money into different DAOs, into white hat DAOs. That happened, I think, last Tuesday. Last Tuesday. And essentially, 2 white hat DAOs were created. Those control now 7.6 million Ether. All of the rest of the Ether of the DAO is inside these white hat DAOs. It is relatively safe because the small white hat DAO has about 353,000 Ether, and only the white hats are in there. In the big white hat DAO, someone who I can only assume is malicious joined and sent us a communique saying that he doesn't trust the white hats, and he also joined that. But he has very few tokens, and there are some ways with which we can kind of stop him from getting this money. Unfortunately, as I said, the dark DAO has nobody else inside. So I thought of a way in order to counterattack this dark DAO. Because the DAO code allows the mother DAO in order it allows it to make a proposal to buy tokens during the creation phase of any child DAO, to buy tokens with a specific beneficiary. This is something that empowers the DAO token holders to strike back at the person who stole their money by making a proposal to give to the curator's multisig or to an account controlled by the white hat hackers some tokens inside the dark DAO. Once that is done, friendly forces, let's say, will have their foot on the door in the dark DAO, and what the media like to call DAO wars will start. It's not the best kind of scenario, but it can make sure that the hacker will never see this money, and also through some methods that I cannot discuss because this is currently a very ongoing scenario. There can be some ways to stop the attacker from reacting. Because the money that was taken is so much, it's essentially about 7% of the total supply of Ether in existence. Because of that, the whole Ethereum community is affected. So the Ethereum developers also started making proposals in order to address it in the protocol level. One such proposal was the proposal for a soft fork. What this means is to create new versions of the mining clients and censor all of the transactions that have to do with the DAO. So essentially it would blacklist certain types of transactions. The plan was to blacklist anything that reduces any contract that looks like the DAO, because the bytecode is identical for the DAO and children DAOs. So no such transaction could go through, except for two exceptions. One would be the curator's multisig, and the other exception would be an account associated with the White Hat group. This actually got developed, it got coded, and new updates were made to the client. And the miners, as you can see from this graph, through a form of voting, voted to use the soft fork. So this was going to happen. So 3 days ago, the soft fork was rejected immediately because nobody saw while it was being developed, not even me, for example, I didn't see it, that this soft fork would not really work because it introduces something very, very dangerous to the Ethereum network. Essentially, it makes it susceptible to DDoS attacks. We could, for example, have something like this Solidity code here, where you have a very costly operation, like a very big loop and hashing some data. And right after that, render the transaction invalid by calling into the DAO. If someone spams the network, a network that has the soft fork implemented with something like this, that means that the miners will be doing a lot of work, and then the transaction would be invalid, so it would not be mined, so no gas costs would be applied to the sender. So that would be a free ride for anyone who wanted to DDoS the network. Of course, there are people who are seeing the cup half full, like Professor Searer from Cornell University, who says that this is a good thing because actually, and it really is a good thing, it shows that Ethereum network is not vulnerable to censorship by the miners. Currently, the other proposal that is on the table, and it's very it's something that really splits the community, is a hard fork proposal. So this is a proposal to change, to create new clients and have a fork. At a specific block, the Ethereum blockchain would fork, and after that block, all of the Ether that has to do with the DAO will be moved back to the DAO account. So all of the accounts that originated from the original DAO would be scanned, and all of the Ether would be sent back to the DAO, and the DAO code would be replaced by a simple refund contract. That would enable all of the DAO token holders to take their money out. It would be essentially a full refund, but it is something that's really controversial because many of the developers of Ethereum do not want to touch the protocol level, even if 15% Ethereum total supply is concerned. So yeah, the road ahead for Ethereum is quite bumpy right now. There is a fork on the road, so to say. Should Ethereum fork in order to provide a full refund back to the DAO token holders, or should a counterattack be made and try to stall the hacker? Maybe some kind of negotiation could go on with the hacker. There are a lot of choices, but whatever happens within the next 2 to 3 weeks will change Ethereum forever, and that's the only thing that I'm certain of. As for us developers of Ethereum, we have learned a lot of lessons. Everyone in the community was stunned by this, and what we have definitely learned is that the ecosystem of Ethereum is definitely not mature yet for totally autonomous contracts. As the DAO proved, that such a totally decentralized contract that is controlled by anybody, that is not controlled by anybody, can prove to be very dangerous because it cannot react fast enough. contracts should have some form of kill switch. It may be introducing a centralized form of control, but at the same time, having a kill switch could have saved the DAO, because someone who could control this kill switch or an escape hatch or something similar would essentially be able to stop the hacker within the first minutes of the attack, and then nobody would be talking about forks or counterattacks. The way that we program smart contracts should change, and we should be programming in a much more defensive way. We should be using assertion-based programming, and even there are talks of different languages inside the EVM with formal proofing, maybe even more Haskell-like, more functional languages without any side effects. Because side effects is what killed the DAO. The side effect of the fallback function, that nobody expected it to be called like that. And finally, and the most important thing, that is that security and auditing of smart contracts should be the #1 priority for any contract that is deployed in the Ethereum blockchain from now on. So that's the end of my presentation. Thank you all for your attention. If you want to follow the latest on the DAO, you can just follow me on Twitter or GitHub. Any questions?